2 billion people around the world do not have access to clean drinking water. And in places where we can do water desalination, it is insanely expensive and requires a lot of energy to produce. It sounds like a crisis that's impossible to solve. But what if I told you that nature has always had the answer? What if I told you that we can produce enough water with no electricity and no CO2 emissions whatsoever? Not only this, but in the process, we will depend on something that happens naturally every single day in all the water surfaces around the world. Until now, if you needed clean water by water desalination, you needed electricity, which comes with tons of CO2 emissions and makes the seawater saltier and dirtier. Your next best bet is on rain, which is unpredictable, it may or may not happen, and not always with the amounts we need. But there is something in nature that could save the day, and that is evaporation. Evaporation happens every day, all the time, with no energy other than the natural energy from sunlight. So what if we can capitalize on something inevitable like evaporation, using natural energy rather than electricity to solve one of humanity's greatest challenges? But how is evaporation helpful in this case? Meet Manhat, a startup inspired by nature itself, and it will tell us exactly how. Salty water evaporates when the temperature rises due to energy from sunlight, and then pure water condenses once the temperature drops. You simply collect the condensed water, which is clean and pure, away from the seawater. When we tried to use this in the current technologies that existed before Manhat, while they created clean water, they produced saltier water in the process that was dumped back into the sea. For 35 cubic kilometers of fresh water we produce, we also produce 51 cubic kilometers of much saltier water that is poured back. Simply speaking, our goal is to produce clean water, but in this process, we produced almost 1.5 more dirty water than clean water. Isn't that interesting? It's like trying to clean your house by vacuuming, but for every room you clean, you end up dumping a ton of dirt in the backyard. Do you realize what we're doing to the environment here? Oh, and did I forget to mention that in this process, we also produce 74 million tons of CO2 emissions? Not cool. The new technology we're talking about took the good, clean part of that process and eliminated the second half of it where we produce the saltier water. It allows for continuous evaporation, and we collect the clean distilled water without the buildup of salt. The question is, if we decide to implement this, would it be enough for all the water that we need? Take a deep breath, because after hearing what I'm about to tell you, you would wonder how we still have water scarcity up to this day. The amount of water that we use for agriculture is only around 3,000 cubic kilometers per year. How about the 2 billion people who do not have access to water? The amount of water they would need is approximately 50 cubic kilometers. Now, if we want to use the water produced by this new technique, we need to know how much water evaporates yearly, right? All oceans evaporate 470,000 cubic kilometers of water. If we only use 0.6% of that water, we can cover all the water we need for agriculture every year. And if we could capture only 0.01% from all this evaporated water, 2 billion people can have access to water very easily. Isn't this mind-blowing? You might think, but we have water desalination plants now. Why don't we just continue with the same thing if it's working instead of using this new technology? Well, apart from the environmental factors that we discussed about electricity, CO2 emissions, and the salt produced, all the desalination plants around the world, with all their might, produce only 35 cubic kilometers per year. Good luck producing all 3,000 cubic kilometers needed for agriculture from that. we would need 86 times more desalination plants with 86 times more electricity, CO2 emissions, and salt. Very bad for the environment and, well, practically impossible to implement. In the Arabian Gulf alone, 350 cubic kilometers of water is evaporated yearly. So if we use this new technology, that's already 10 times what we produce by all desalination plants around the world. And that's not even the best part. Look at this. This whole idea depends on how much area you can cover to cap the evaporated water and collect the condensed water. So think about it. The larger the area you cover to collect the evaporation, the more clean water you will get. So it is true, you need large areas for this, but here's the fun part. If this area we use for water collection is the same area we use for farming, we don't need any extra space for this technology. We integrate the irrigation of crops with this technology and voila, floating farm solutions. It's like using your hat to catch rain while also growing a little vegetable garden on top of it. Well, you get the idea. You're simply purifying the water and using it immediately where it's needed without the need to move it somewhere else, which is a long process by itself. Manhat is on a mission to make water scarcity a problem of the past. By using the natural water cycle, they offer a solution that works with nature, not against it. We thought this research was really interesting and worth sharing, and it has the potential to have a big positive impact on the industry if applied. Imagine just using the sun as an energy source to evaporate water. We can get fresh water without any bad chemicals in the environment. No electricity, no CO2, no salt. It's environmentally friendly and accessible to everyone, anywhere. This could be our reality, and we hope that this video inspires action to bring this game-changing technology to the world. If you're interested in exploring how to take this idea further in the industry, we'll leave the contact information for you. And if you know any other research ideas to be applied in the industry, let us know in the comments. And don't forget to subscribe to the channel for more cool scientific research that has an impact.